moving right along in our study of algebra, solving algebraic equations, we're going to look at the next level of complication. And that's when one side of the equation has like terms on it. So I'm going to begin with the example 5 equals x plus 8x minus 4. And as we can see, the only thing that's different here is one side of the equation and the other. If you have like terms on one side of the equation, and we have them here because we've got this x and we've got this plus 8x, the first thing I want you to do is to combine the like terms. Okay? And remember, when we learned to combine like terms, we did box, and it's important to box and include the sign in front of the number because you could get confused if you don't. So, combining these, I have 5 equals x plus 8x is 9x minus 4. As every single time when you have an equation, you say, what do I have on one side? What do I have on the other? Now, this is what we've already done before, so rather than write down all the steps, I'm just going to say solve. Because hopefully you know that in a two-step equation, in other words, when there's more than one thing we have to get rid of to isolate x, we're going to do the additions and subtractions first, and then the multiplications or divisions. So, you can see I need to get rid of minus 4 and times 9. What I'm going to do first is add 4 to get rid of that. If I do it to one side, I do it to the other. That gives me 9 equals 9x. To undo 9 times x, I divide by 9, and that means that x equals 1. So this is basically it. It's only one step more complicated than what you've done before, but it can. I'm going to combine two of them into one example of an equation. Some of your homework tonight has fractional coefficients. In other words, the number in front of x is a coefficient. So it might look like this. Okay. So you also can see that you have two what we call constants, -8 and -2. I'm just going to do this and explain it as we go along so that you get the idea. I am going to combine my like terms first. They are 3/5 x, and if there is no sign, I hope you know that's positive. And this is what I mean by including the sign in front of the number. This is positive 3/5 minus 2/5 or plus -2/5. 3/5 minus 2/5 is 1/5 x. Now, I'm also going to combine my constants, or my plain old numbers. -8 and -2 gives me -10. If you are in the camp that still finds it easier to add the opposite, you're welcome to do that. Eventually, it's probably easier and more streamlined to get past that. But you do what you need to do to become accurate. Okay, now we've got a two-step equation. I've got to get rid of -10 and times 1/5. To do that, opposites undo, and I'm going to begin with the additions and subtractions. That leaves me on the left side, 1/5 x. On the right side, 15. To undo 1/5, I'm going to do the fraction destroyer. I'm going to multiply by the denominator. That takes out the 1, cancels out the 5s. 15 times 5 is 75. So that's another type of things. This involves two things that are on your homework. First of all, you're going to have fractions. I think they all have common denominators, so it's just a matter of adding or subtracting the numerators. And you will also you will also need to combine your constants. Is an application of this sort of idea is when we have shapes. Let's say our shape looks something like this. Pretend the lines are straight and it looks better. But anyway, if this is x, this is 1/3 of x, this is 2/3 of x, and this is x plus 20. And I'm sorry that this doesn't look so perfect. The lines aren't straight and whatnot. But anyway, we know anytime we have a quadrilateral, a four-sided figure, the sum of the angles adds up to 360. Just like we know that the sum of the angles of a triangle is 180. If you tend to forget that quadrilateral, just think about the four right angles of a rectangle. 90 times 4 is 360. So if I know that all of these angles add up to 360, I can write an equation. I can say x plus 20, that's this one, plus x, that's this one, plus 1/3 x, that's this one, plus 2/3 x, that's this one. I might not know what x is, but I know that if I add all of these angles together, they have to add up to 360. Now I'm going to follow what we just learned about like terms in equations. I have 1x, 2x, and 1/3 of an x and 2/3 of an x. 1/3 and 2/3 is another 1. So I have 1, 2, 3 x's, and then plus 20 is equal to 360. And now I need to subtract 20. Oh shoot, I thought I did this in a way that it added up okay. This is not going to come out to a whole number, but you get the idea. 3x, and now I'm going to divide by 3, and that gives me x is 113 and 1/3. But all the ones in your homework are going to come out evenly, so don't worry about that. This is the important thing, getting the equation based on looking at the angles.